Today's video is going to be a little bit different. Up until now, I've said, here's a parallelogram, and then now apply the properties of a parallelogram. Today, instead of telling you here, this is a parallelogram, I'm going to ask you, is it a parallelogram? So you have to determine whether or not it's a parallelogram. There are 6 different ways that we can prove something to be a parallelogram. First way is if both pairs of opposite sides of a quadrilateral are parallel. That's the definition. Now you can't just have one set, you have to have both pairs of opposite sides being parallel to each other. So if you have that, then yes, you can say it's a parallelogram. If both pairs of opposite sides are congruent, then it's a parallelogram. Just like the last one, we're not just looking at one set, we have to have both pairs of opposite sides to be congruent. Now when we get into condition number 3, this time we only need one of them, but they have to be parallel and congruent. So the difference is, in our first example, we have both pairs being parallel, so top, bottom, left, right. And the second one, we need them to be congruent. So top congruent to the bottom, left congruent to the right. And number 3, now instead of being both, I need one, so we can just pick any one. Top, I need to be parallel to the bottom, and I need to be congruent to the bottom. So instead of being both being one property, I need one set of opposite sides to be both parallel and congruent. All right, so number 4, if both pairs of opposite angles of a quadrilateral are congruent. So we're back to that word both, so I need to show that both sets are going to be congruent to each other. If the diagonals of the quadrilateral bisect each other. So again, they are bisecting each other, so I can't just show this. That would not be enough information. I have to show that both diagonals are being bisected. And the last one is if one angle is supplementary to both of the consecutive angles. So we have 4 angles. If I just pick this one, in order for it to be a parallelogram, I have to show that this angle right here is supplementary to both of them. So let's say that this is 100 degrees. I would need this to be 80, and I would need this to be 80. I can't just show that one is supplementary. I have to show that both consecutive angles, so the angle on each side, are going to be supplementary. So we're going to use these ideas to determine whether or not it is going to be a parallelogram. When I look at the first one, I've got the top is congruent to the bottom. I've got the left is going to be parallel to the right. So this is going to be a no. There's lots of different ways that you can describe this. So one way is no. You need one pair to be both parallel and congruent. Or you would say that you need both to be congruent or both to be parallel. But right here we have one congruent and one parallel. We would need the same side. So if I could say that this was parallel to this, now I have one pair that's both parallel and congruent. Moving on to our next one. Would this be a parallelogram? No. We would need the consecutive ones to be supplementary, which it may be, but we don't know that it is. Or we need them both to be congruent. So let's go with that one. So no, you need both sets of opposite angles to be congruent. So now we're going to move on, and we're going to say that we have our quadrilateral. So what we want to do here is we want to come up with what additional information is needed to prove it's a parallelogram. In this diagram, we have the left is being parallel to the right, and we have the top is congruent to the bottom. We talked about in the last one how that's not enough information. In our last one here, we have that wasn't enough information to prove it was a parallelogram. So what would we still need to know? In the example we showed up here is that we would need the top and bottom to be parallel, and that way we have one set that is both parallel and congruent. That's not the only thing we could have done. We could have said, okay, well, this side is congruent to this side, or AM is congruent to HT, and if I did that, then I have the left and right being both parallel and congruent. All right, here comes our last problem. This is going to be a quiz and a test and a final question. Based on the picture, the quadrilateral is a parallelogram because. So for this, it is going to be very important that you are very detailed in your explanation. When I look at the diagram, I have to decide, how do I know it's a parallelogram? In this particular case, I see angles given to me. This angle is 130, this is 50, and this is 50. So the reason why I know it's a parallelogram is one angle is supplementary to both consecutive angles. And the explanation is very important. So again, based on the picture, I know it's a parallelogram because one angle is supplementary to both of the consecutive angles. Now that I know it's a parallelogram, I can apply any and all properties of the parallelogram. So I use this to determine and to prove it was a parallelogram. Now I'm going to use different information. Now that I know it's a parallelogram, I'm going to use the fact that opposite sides are congruent to write my equation. 34, I don't know what that's congruent to, but I know since the top is congruent to the bottom, I can set up 8x plus 10 is equal to 50. We move our 10 over, getting 8x is equal to 40, divide by 8, and we find that x is going to be equal to 5. So for these type of problems, you're going to have two parts to it. One, what property are you provided with in the diagram that allows you to show it's a parallelogram? And then you are going to apply a different property of the parallelogram to solve for x. All right, and then that's it for today's video.